Hi guys, and welcome to video number 184. This video is on trigonometry in 3D shapes. Now, trigonometry, as I've mentioned previously in the trigonometry video, is the branch of mathematics that allows you to find missing side lengths or angles in triangles. A right pyramid is a pyramid that has a regular polygon as its base, and the apex is the top point of a shape. Opposite, adjacent, and hypotenuse are the names in which we label the sides in right-angled triangle trigonometry, and the inverse is undoing something. So in this instance, we undo the trig ratio by inversing it. Now, in the method, it states you need to identify the right-angled triangles in the problem that you need to use trigonometry on. All right, so you get a 3D object and you need to slice it into right-angled triangles to work stuff out. We're going to use trigonometry to find the missing length or angle, potentially, then use it again to find what you need in the problem, or we're going to use trigonometry to find a missing thing and then use that in the next calculation to find whatever it is that we need to. Could be a volume, a surface area, or something like that. And it's more than likely we're going to mix in a bit of Pythagoras as well, because Pythagoras is easier to use to find missing side lengths. If you've got two sides, you can always use Pythagoras. So most of the time we'll be able to do that. Now, we're going to start off with question number 1. And this is a tough topic if you're not great at visualizing things, but if you can visualize stuff and slice out those 3D out of those 3D shapes, those 2D right angled triangles, you should be okay. All right, if you follow my steps of what I'm going to do, I'm going to show you. So first question's simplest version of a question you could get on this, but it's still pretty tricky. So shown as a cube, find the angle CAG, give answer to one decimal place. So C to A to G, we're going to draw a line that joins C to A and then A to G, right, roughly. Okay, and then what we can see there is we sliced out a right angled triangle. There's our right angle. Okay, that's definitely a right angle. And what we need to do is work out that angle there. Let's call it angle X. All right. And what we also need to do is remember that this is a cube, okay? So each of the side lengths is 6 centimeters. So I'll just label that on there. Now that is pretty useful. There's also, and this is very relevant, another right angle triangle just down here. If we look at that as the base, all right, imagine floating above it, you'd see that as a right angle triangle as well, okay? So ABC is a right angle triangle, okay? And we need to work out the length AC, right? Now we can do that. I'll just draw ABC there, if you like. There's ABC. There you go, right, which is 6 and 6 centimeters, 6 centimeters. Okay, so we need to work out this length AC. Why do we need to do that? Well, we need to do that because there's only one dimension on this triangle ACG that we can use, and we can't just use one dimension. That doesn't help us work anything out. We need two things to work out the last thing. So we need two side lengths to work out the angle, and then we can use our trigonometry to do that. So in the world of Pythagoras, let's work out A to C. We're going to do the square root of 6 squared plus 6 squared because we're finding the hypotenuse, okay, longest side, which you should know by now if you watch the rest of my videos in this topic. 6 squared plus 6 squared, that equals 6 root 2. All right, so let's label that 6 root 2. You could label it on this diagram as well if you wanted to. Now we're going to get this triangle, this right angle triangle that we identified, first of all ACG. Going to get that out of there. Okay, there's our 6 centimeter side there because that's G to C or C to G, whatever way you want to look at it. There's A, and now A to C we know is 6 root 2. We just worked it out. So in this instance, we want this angle, and the only way we can work out that angle is to use right angle triangle trigonometry. Not the only way, but the neatest, easiest way. Now, so we've got to label the sides. Okay, so if you're not sure how to do this, please go back and watch the video on it. But this is opposite, this is adjacent, and this is hypotenuse, OH and A. Then we write out SOHCAHTOA, SOH, CAH, TOA. Decide which one of these three trig ratios we're going to use, sine, cos, or tan. Now we've got the opposite and the adjacent, so O and A is the one that we're interested in. So it's not this one, not this one, it's this one. Have our formula triangle for it. Okay, TOA, right, cover over T. T stands for tan of the angle because that's what we want to work out. So tan of the angle is equal to, not the angle itself, but tan of the angle is equal to 6 over 6 root 2. Write that down. And then what we have to do to get always in trigonometry, the angle on its own is inverse. Okay, so we inverse the tan, so we get tan to the minus 1 All right, that's shift and tan on the calculator. Opens up a bracket, 6 over 6 root 2. That's the calculation we can type in to find out our answer. So angle CAG equals, let's type it in. Right, shift tan, tan to the -1 comes up. Fraction button, 6 over, answer I had on the screen was 6 root 2, so I'm going to use the button, the answer button, and then 35.26. We want it to one decimal place, so 35.3 degrees. All right, I hope that makes sense. It's a tricky problem, but it's just Pythagoras and trigonometry combined. It's about slicing it up and finding that bit that you need. Okay, right, let's have a little look at this second question there. Okay, now the second question asks us to calculate the volume of the right pyramid shown. So we're thinking about how do you work out the volume of a pyramid. First of all, that's the thing that you need to know how to do, and it's 1/3 of the surrounding prism's volume. Okay, so we think about this: a right prism, 4 sides, square base must be, because it's a regular polygon. All right, if it's a right pyramid, it's got a polygon on as the base that is a regular one. All right, so all the lengths are the same, so therefore this must be a square. Okay, therefore the surrounding prism of this pyramid would be a cuboid. Okay, we don't know what this height is. Okay, we are going to have to work out what our height is. It tells us the apex E is over the center of the base, so that's good. So we can just go and draw a little line, or as straight a line as we possibly can, to the center there. That's the very, very center. Okay, and we're going to give our answer to 3 significant figures, so a little bit of work to do here. But it all starts off with working out what this height is. We need to know what that is. Let's call it H. H for height. Now, we could do this a couple of different ways, right? Well, let's think of maybe this way. All right, so here I'm going to split that in half, exactly in half, right? And we're going to go and work out what this length here to here is. Okay, this length. Let's call that point M because it's in the middle. All right, so we're going to work out A to M, and let's call that point P because why not? So we've got another little right angled triangle going on here. All right, you can see that I've got that triangle. Imagine you're looking down upon that triangle. So here to here is going to be 30 centimeters because it's halfway A to B. All right, and then here to here is also going to be 30 centimeters. All right, so let's draw that little right angled triangle out again. All right, A, M, and P. A, M, P, 30, 30, right angle, M, P, and there's A. All right, and we're working out A to M because we need it again in that calculation because we got this angle this time. We want to work out what that height is. Okay, and again we can use trigonometry to do that. So let's work out A to M. So A to M equals the square root of 30 squared plus 30 squared, and that equals, move this over here so we're out of the way a little bit. Oh dear, that wasn't anywhere near 30 squared plus 30 squared. There we go. So 30 root 2. Okay, so that length there is 30 root 2. 30 times by root 2. Keep it in that form. It's the most accurate thing that you can use at this stage. You don't want to round any of your calculations at this point. Now, that's that length there. So we're going to draw this right angle triangle out here. Okay, there's our H that we've labelled it. That height, perpendicular height. All right, a perpendicular height because that creates a right angle. There's our 60 degrees there. Okay, and that length there is, if I label it A to M to E, okay, that length is the one we just found, 30 root 2. Right, so let's use that to work out H. Now, this time we're doing trigonometry, but we're doing the finding a sides version. All right, but still start off with writing out SOHCAHTOA, SOHCAHTOA. Okay, then we're going to decide that we want the opposite and we've got the adjacent. So it's TOA. All right. Again, we're going to draw the formula triangle TOA. Okay, but this time we're working out opposite. So we're going to do O equals tan of the angle, tan of 60. multiplied by the adjacent is 30 root 2. It could be something you were asked to do without a calculator. It'd be pretty harsh if it was, but you know, it could be because it's one of those trig values that we do have to learn. But I'm still going to use a calculator because I think it's a tricky enough problem as it is. Multiplied by 30 root 2. That's our opposite side length. O equals 30 root 6, I think that was. Okay, now that is going to allow us to calculate the volume of that prism. So let's just have a little look, see what that is. Yeah, 73. It's a reasonable number, isn't it? It makes sense, right? So I'm just trying to figure out where I can write this. 30 root 6. I'm going to rub the rest of that out, okay? Because we're going to start that just the calculation for the volume now, right? So there we go. We got to that point with 30 root 6. And that is our value of O, the opposite side, or H, as we labelled it there. All right, let's call it H equals 30 root 6. And then I can get rid of that bit as well. Right, so we need to work out what the volume of the cuboid would be here. Now, the volume of the cuboid would be pretty easy now. That's 60, 60, and then multiply it by 30 root 6. So the volume of the prism, let's put volume of the, sorry, not the prism, the pyramid, not the surrounding prism. The volume of the pyramid, all right, would be 1/3 of the surrounding prism's volume. So 1/3 multiplied by 60, multiplied by 60, multiplied by 30 root 6. Okay, and the volume of the pyramid, nearly said prism again, is equal to 1/3 multiplied by 60 multiplied by 60 multiplied by 30 root 6. There you go. So the volume is that 88181. 88181. Point something. 630. Dot dot dot. And then we've got answer to the 3 significant figures. So 1, 2, 3. There's our 3 significant figures. That's going to round that up to a 2. So that's going to be 882 and then 0, 0. And that's in centimeters cubed, right? Because it's a volume. So it's a little bit tricky, a little bit extra to do. You did have to know that the volume of a pyramid could be worked out by working out the surrounding prism's volume and then dividing it by 3, or 1/3 of the surrounding prism's volume. Okay, right, moving on to the third and final very, very tricky question. This is a lovely question that I found on a group, a teaching group online, and someone was asking how to do it. So I thought, this is coming up, one of the things that's coming up, I'm going to use a very, very similar version of this question, and hopefully they'll have a look at it and they'll understand what they need to do to answer this type of problem. And it is a bit of Pythagoras and trigonometry in 3D contexts. There is a formula you can use, but there's no point at GCSE learning that formula because it's not one you're expected to know. You use Pythagoras and trigonometry to work this out. This is what you would be expected to do here. So we need to calculate the surface area of this right pyramid. Now it's a right pyramid, which means the triangle on the base is an equilateral triangle. Okay, it tells us that as well. All right, I wrote that in the question because I thought it was a bit more friendly to do that. So ABC is an equilateral triangle, and I've just noticed there's a D on there. It shouldn't have a D on there. It should be an and. I always read these, and I do make these mistakes, and I am so sorry for that, but I just keep missing them. Anyway, ABC is an equilateral triangle, and D is the apex of the pyramid. Okay, so that means that point P here, all right, is directly below D, which is also written there. Okay, so is the apex of the pyramid. M is the midpoint of AB. Okay, answer to 3 significant figures. Fine. So the process here is, again, let's figure out where we need to start. Okay, ultimately we need to work out what this length here is, M to D. All right, imagine unfolding this shape, all right, and you'd need to work out the area of each of its faces. If you unfolded this shape, you'd have a net where you'd have an isosceles triangle there, and then a congruent isosceles triangle there, and a congruent isosceles triangle there. and you'd have the equilateral triangle in the middle. All right. So this is a height that we do not yet know. Okay, we know the perpendicular height of this pyramid is 17 centimeters. Okay, we just need to work out what that length there is. Right. So for us to be able to do that, we're going to need this length here. All right, and we don't have that length there, so we need to get that length there. Now, what I would do in this instance, might not be the only way, but this is how I would attack this problem, is I would know that this whole angle here, because it's an equilateral triangle, I know that's 60. So I know that that then is 30 degrees. Okay. I also know that because this is the midpoint, I know how far this is, because I know AB is 8 centimeters. So I know that that's 4 centimeters. Right. So what we've got is the ability now to work out P to M, because we've got an angle, we've got a side for triangle MPB. So I'm just going to draw MPB out. It's always a nice idea to do this. Just draw the 2D shape out as a flat version. Okay, even if you can see it really well in the diagram. So we're working out this length here. That's our opposite length, all right, opposite the angle that we've been given. So that's O, all right, and that's A again. So that's 4 centimeters. So again, we're using the tan ratio. So TOA, don't have to go through the whole process of writing it all out. If you know for certain O and A, that's the ones we're looking at there. Fine, let's just use that. So O equals tan of 30 multiplied by 4. All right, so O equals, let's just type that in, 4 root 3 over 3. Okay, so 4 root 3 over 3. That is that distance from there to there. M to P is that distance. Okay, so let's write that down. In fact, I'll write it over here. MP equals 4 root 3 over 3. Really useful to know that, because then we can use it in this calculation to work out what this length here is. All right, now that we can use Pythagoras for. Okay, so I will do that. I'm just going to get rid of that work in there in the middle, because there's not enough space really to write it all. So this is the next step. Okay, so let's draw this triangle. M to P to D, there's our right angle. We know that that length there to there is 4 root 3 over 3, and we know this is 17. Okay, so for us to work out M to D, this perpendicular height of the face, the isosceles triangle, one of the faces, we need to use Pythagoras. So that's going to be 17 squared, and we're finding a longest side here, plus 4 root 3 over 3 all squared. All right, let's type that into the calculator and find out what we get. That's M to D. M to D is this length here. .15, etc. Just put ... Okay, now that calculation there is going to get us, or give us the ability to work out the area of this face, ADB. Okay, so ADB, this isosceles triangle here, right, we've got that perpendicular height D to M. Okay, so ADB has an area of this length multiplied by 4. Okay, so our answer multiplied by 4. Okay, that's what we need to do. So that's why I'm doing it in the same part of the calculation here. And then I can write that down on the side and clear the screen, because we've got a little bit more work to do on this one as well. So that is got to multiply it by 4, because it's half the base times the height for an area of a triangle. So that's 68.62. Just write that down. 68.62 ... and then there are 3 of those exact same triangles, so we just need to multiply that by 3. Okay, and that equals 205.87. So let's do answer times 3 205.87 centimeters. Fine. Right, let me get rid of the rest of that and then show you what you need to do for the rest of it, because we need to factor in the base area as well, and the base area we need to use a bit of Pythagoras again, all right, to work out the perpendicular height of that triangle. Okay, so using Pythagoras, we've got CMB, let's say that we've got that triangle there, and we've got that side length of 8 centimeters, and we've got that side length there of 4 centimeters. So we're working out this length here. That's one of the shortest sides. So this time we're working out the square root of 8 squared minus 4 squared. Okay, and we're working out C to M. That's the perpendicular height of our equilateral triangle. And that is going to equal something. Okay, so let's just write that down. I've got that written down there already. 37477. There's the rest of the decimals on the end of that. So yeah, let's go back there. Now, square root of 8 squared minus 4 squared equals 4 root 3. Could have done this bit first, actually. It doesn't really matter. So as long as we've got 3 significant figures, it's fine. So 4 root 3 is this length here, and that's our perpendicular height. So all we need to do is multiply that by 4, right? And then we've got the base of this whole ABC triangle. So the equilateral triangle ABC, right? There's our perpendicular height, 4 root 3. Okay, this is the length of 8 centimeters all the way along the base. So half the base times the height, just timesing that by 4. And there we go, 16 root 3. So 4 root 3 times by 4 equals 16 root 3. Okay, and that's the area of the equilateral triangle on the base. So all we've got to do is add that on to our answer, okay, of the 3 isosceles triangle faces. And then we've got all 4 faces, areas, and therefore we've got the surface area. Okay, so I'm just going to add that on to 205.87 37477. All right, I think that was the rest of the numbers I've written there. It doesn't really matter because it's not the accurate bit. And then you got the answer. All right, so we've got the final answer of, let's get rid of that now, 233.586. So surface area equals 233.586, and then to 3 significant figures, 1, 2, 3. So 234 centimeters squared. Okay, that is a very, very tricky problem. If you get faced with that at GCSE, I suggest that's definitely a grade 9 question. I've seen those sorts of questions on further maths papers, but nothing like that on GCSE. But it's a nice question. So thank you for whoever posted that, and hopefully you see this, and hopefully it helps whoever it was that needed the help. So yeah, cheers. This is the longest video I've ever done, and my arm hurts. So I will be leaving now and going to get a drink. So thank you very much for sticking with me and watching it. I hope you've enjoyed it. If you did, please like, subscribe, and share with other people that this is useful. All right, cheers guys, take care, bye bye.